Oh, yep, I can give you one of those. Yeah. Because now I'm out, so I hope you got one last time. All right. Any questions at all before we go over these? Things going okay? Yeah. All right. So I asked you to look at these problems for today. Let's give them a shot. See how they go. Yeah. All right. So let's look at a few of them, and then we'll probably start law of cosines today. So I'm thinking on Monday we'll do a quiz over law of sines. So we'll do, pardon me. We'll do one triangle problem and then one application problem. So those will be two problems on the quiz. We got a test coming up. Done. For Monday, maybe? Or is it Wednesday? Whatever day it is. It's not next week, it's the following week. It's either Monday or Wednesday. I can't remember which day. But might be the Monday. 14th is a Monday, so sounds like something I would do. All right, so let's set this one up. Well, how did you draw your triangle? What did you do? Or how would you draw your triangle on this one? I'll label the base 5.6 miles. Okay. Sounds like a good plan. Make a base 5.6 miles, so you must be making your A and your B here. Yeah. And then what else do we need? Okay, so probably need some other point out here, right? Some C out here. Your angle A should be 46. And your B should be 55. And the problem's asking you to figure out what? Relative to the triangle, what's it asking you to find? The two other sides, right? So basically it's asking you to solve the triangle without worrying about the third angle, right? It's just an application problem asking you basically to solve the triangle. All right, so let's label the two sides that we need to find. So we've got A and B. So what would you need to set up to solve for A? Oh, I guess I do need to find the other angle, don't I? So I guess it really does ask you to figure out the whole triangle. I guess it did ask you to solve the whole thing. What did you get for the other angle? What would you do? Good. 1 by 80 minus the sum of the other two. The other two add up to what? 101? So 79? We agree with that? Okay. So now what would you have? Good. Are we okay with that? The other equation would look almost exactly the same, except the left-hand side would be what instead? And then same thing on the right side, right? Agreed? So if we solve for A, you would have 5.6 sine of 46 over sine of 79. I need to put my watch on Do Not Disturb because apparently now is the time everybody's decided to email me this morning. I haven't had any email all morning, and then my watch just buzzed like 5 times in a row. The other one's going to look like 5.6 sine of 55 degrees over sine of 79 degrees. Anybody get those values?
got A is 4.10.
Say it again.
4.10.
4.10, is that what you said?
Yep.
Okay. And B?
4.67.
0.67. Both of these should be in miles, since the 5.6 was given in miles. Does it make sense that the B is longer than the A? And that the C is actually the longest side? Does those three make sense relative to what we have for angles? Yeah. A is the smallest angle, so A should be the shortest side. C is the biggest angle, so C should be the biggest side. Yeah? Are we okay with that? Oh, squeaky. Sorry. Okay with that? Goodness. All right. How about the second one here? Everything's going to be about setting up a triangle, of course. You drew a tree on your paper? Okay. Let's see, do I have green in here? I bet I do. If I can get it open. Got some green. Maybe some brown. Have brown? No, I don't really have brown. We'll use that. It's got some glitter in it, but it's brownish. How's that? That's about as artistic as I get. That's about all I got. All right. There's a tree. Come on. Open back up. There we go. Jeez. I mean, I could write in the brown glittery color, but I'd rather just do it in black. All right. What about this tree? What is the tree on? A hill, all right? So make a hill. What are some things that we know?
The distance is 120 feet from the base of the tree.
Okay. What else? Yes.
I don't think I have this.
Did anybody take tubes? I don't have, because I gave it out on Wednesday. I don't have the next. Yeah, I don't have an extra one right this second. I'm sorry.
That's okay.
I gave them out at the end of class on Wednesday. I don't have an extra one. Sorry. Oh. There you are. All right, cool. All right, what else do we know?
The angle of elevation of the top is 37 degrees.
Okay, so how do we measure angle of elevation again? What is it always based off of? No matter what the problem is, the angle of elevation starts where? Yeah, at the bottom and goes up, right? Angle of elevation is always off the horizontal and up, right? So I need to put a horizontal in here. And then to the top of the tree, this angle is 37, right? That's what angle of elevation means, right? Off the horizontal up. Angle of depression is off the horizontal and down. Elevation, depression. This also would be the sum of my dance moves. That's all I got. No one wants to see me dance. It's fine. All right. What else do we know then? The angle of elevation to what? Not only the top, but the bottom. So where should I be labeling that 22 then? Yeah, on where at? Here? Remember, angle of elevation is always measured off flat up. Is this flat? No. So it can't be there. Where does it have to be? Ooh, hey, I lost my line. Where does it have to be? There's only one more angle. Yeah, it has to be right here, right? This has to be 22 degrees. Angle of elevation is always measured off a level. Okay? That hill's not level, so I can't measure my angle of elevation off the hill. It has to be off the horizontal. Now, can we figure out the one in the middle, though?
Yes, subtract 2.
Yeah, subtract the two angles. So in here it'll be 15. Gosh darn it. Here it'll be 15. Now, I think we're going to need one more angle to help us figure out the height of the tree, right? The tree is opposite that 15-degree angle. So far we've got something that looks like 120 here and 15 here, right? But I need one more angle. We can figure it out. Let me help a little bit. If I draw that perpendicular down, can I figure out what that angle is at the top? Yeah. It'd be 90 minus the 37, right? So the angle at the top should be, what, 53? You're not writing. 53. Oh, for heaven's sake. I'm assuming the tree is growing straight up and down relative to the horizontal. But the tree is slanted, then that's a different issue. Okay. All right. So now can we figure out the height of the tree? If this is my tree, I'll just call it T for tree. What equation would you set up?
I found the third angle first. Oh, I guess you don't need to.
Yeah, you can, but I don't think you need it in this one. So what equation would you set up?
Should be sine 53 over 120.
Okay.
Sine 15 over 2.
Yep, I agree. Yeah. We have to assume the tree is going straight up and down, which trees tend to do, right? They don't usually tip over because their root system doesn't hold on very good. They'd rather be straight up and down, even if it's on the side of a hill. Just go to the mountains, right? They'll go straight up. They don't lean. Did we get a value?
38.89 feet.
Good. Hard part is getting it set up, right? Once you get the triangle, the problems are all the same. This one okay? You want to do the next two too? Yeah, okay, we can do that. I'm happy to do them. Oh, this one's a long, worded one. I borrowed this from Dr. Stickles, so she was apparently pretty creative when she wrote this one. All right, I'm going to estimate the distance between two trees. They've got tree A on one side of a river. Measured the distance from tree B to a third tree on the same side of the river. I don't know why. Let's see AB. Oh, I guess I did not do a very good job of where I put my A. Given the size of the angle. Let me move my A. Sorry. ACB is 25. CAB is 110. And I said the measure of the B to C is 120. And I want to figure out the distance from A to B. Well, once I got the picture set up, that one's not too bad to do at all, is it? Wait. Things are set up. What would you set up if I wanted to figure out this is, since it's across from C, it's little c, right? What equation would you set up?
Sine of 25 over C equals sine of 110 over
110 over 120. Again, like I said, once you get the picture set up, it's just a matter of doing the same stuff we've been doing with, pardon me, with the triangles. What did you get for that value?
53.97 feet.
53.97 is that what you said? Everybody okay with that one? Work on the last one for a minute and then we'll chat about it. Make sure we're all comfortable getting these kinds of problems set up. Ready to talk about it? Yeah. All right. So I drew a quick picture. Said the balloonist was going across at 5 miles per hour. There's an angle of depression at one point. Looked back, there's an angle of depression at a different point. So crossed over the peak at some point, right? All right. So angle of depression again goes from horizontal downward, right? So we should be able to label one of these as 43 and the other as 56. We agree with that? There is another piece of information we know about this triangle. We just had to use a little bit of work to find it. What other piece of information do we know? Well, I got the two angles of depression, right? What else do we know? Oh, you mean this one down here? Yeah, we can get that one too. I agree. Okay. Yes. Yep, I know the distance between those two and how to find it.
You take the 36 minutes, convert to hours, and then 5 minutes per hour.
Yeah, good. So that distance here would be 5 times the 36 over 60. Yeah. So you get 3. Okay. Pardon me. Are we okay with that so far? All right. So notice in this case, rather than, it's not directly asking us for one of the lengths of the sides. This problem's actually asking us for the length of that side, isn't it? How high above the peak the balloon is crossed, right? What's that length? But I do need to do an intermediate step, don't we? I need to find one of the other sides. So, because once I find one of the other sides, then I can just use sine to help me get that side, or this side, I should say. All right, which side do you want to find? The one across from the 43 or the 56? It literally does not matter which. Which one do you want to do? The 43? Okay. Find this one over here. I'll just call it X. We also do need to know that third angle, right? If I'm going to do the one that's across from the side of 3. What is the third angle here? 81. So now what equation do you need to set up to solve for X?
Sine of 81 over 3 equals sine of 43 over x.
Good. So we can multiply by 3 and divide by sine of 81 to get us the X value. What was it? Thank you. Is that what others got? 2.07? Awesome. Now that we have that, if I call this side H, because that's what it really wants, is that height between the balloonist and the top of the mountain, what would you set up? Good, yeah. We've done problems like that before, right? That's just a simple right triangle one, isn't it? So we do the sine of 56 is H over 2.07. Solve for your H. And what did you get for that one? 1.72. Is that what you said? Okay. And the units would be miles. Good. What I would say is that balloonist is high up. You're going over the top of a mountain and you're another 1 3/4 miles above it. I hope you have some oxygen with you at that point. That one okay? Any questions on getting these set up? That's going to be the hardest part, right? Because once you get it set up, it's just like the other problems we've been doing. Any questions on the setups at all? Yep, what's that? Yeah, the language, it takes practice to get the language down. I do agree. All right. So we've talked about doing these triangle, solving these triangle ideas using law of sines. But with law of sines, basically we need to know a couple of angles. If we know a couple of sides and an angle, we know that one can be problematic, right? That was the one where we might get two triangles. So we haven't done the congruence theorems of when you're given two sides and an included angle, or when you're given all three sides. So that's what we're going to use what we refer to as the law of cosines. So let's do a little bit of work showing where the law of cosines came from. And apparently I did not get this added in. Let me do that real quick. Well, the Wi-Fi in this room is terrible because my computer does not like to connect to it quite often. And I need the Wi-Fi so that I can get this printout put in here. Give me just a sec. Sorry, I thought I had it in here already, and I did not. Okay. My apologies. Anybody have intermission music to play while I'm doing this? Jeopardy theme, something along those lines? All right. Sorry about that. All right. So let's take a minute or two to talk about where the law of cosines comes from. So to get the law of cosines, let's say we have all four pieces of information that are labeled on here. So let's say we have the three sides and the included angle. We're going to set up an equation so that if we have three of those pieces of information, we can get the fourth. Okay. So what I mean by that is if I know all three sides, and that would be your side congruence theorem, you could use law of cosines to figure out what the gamma is. Okay. Or any of the other angles. If you had angle sides, you could figure out the opposite side that's missing. The two sides of the included angle. So that's where we're headed. But for argument's sake right now, let's say we have all four of those pieces of information, and we're going to set up an equation that has to relate them. Okay? As a helping piece here, I've drawn in this perpendicular side, but I don't know where it intersects the other side, right? I don't know where that actually hits the other side. So if I called this distance x here, what would that distance be? In terms of b and x, what would that side be? B minus x? Right? We agree? Okay. All right. So let's see what pieces of information that we can get out of all of this, okay, from just the trig that we know. So again, what I said was, let's suppose that we know what the three sides are. Obviously, I don't know what x is. When I'm done, I want x to go away. So I need to get a couple of equations so that I can make x go away. Is our goal here, okay? So let's look at this triangle here on this side. Certainly there's one relationship that we can come up with for x in terms of gamma and a. What could you use to relate x, gamma, and a in that right triangle, the right side right triangle? Okay, I can do cosine, right? We know that cosine of gamma would be x over a, right? We agree with that? Okay. Or your x then would be a cosine of gamma. right? All right. So now I know that this piece right here, then, I could write that as b minus a cosine of gamma. We agree with that? Likewise, I could find this side as well. If I call this h rather than x, and again, looking at that right triangle on the right-hand side, what trig function can you use to relate h, gamma, and a? Sine? You'd have sine of gamma is equal to h over a, or h is a sine of gamma, right? Okay. So finally, we can put some pieces together. Let me just draw this off to the side so everything's not such a mess. That's the left-right triangle, isn't it? With the sides we just found. Can you give me now an equation that relates all of that information together? What can we use to relate all of that information together? Make an equation that relates all four of those pieces that we have. The right triangle. I have 3 sides. Yeah, I can use this with Pythagorean theorem, right? So if I use the Pythagorean theorem, we would have a sine gamma squared plus b minus a cosine of gamma squared equals c squared, right? Now let's just multiply some things out and see what happens. Here I would have a squared sine squared gamma, right? I can just since it's a product, I can distribute the square to both pieces. What do I have to use in the second piece, though, to multiply that out? Can I just take b squared minus a squared cosine squared gamma? Does that work? No, what do we need to do instead? We gotta FOIL it, don't we? So you'll get a plus b squared minus a 2ab cosine of gamma, and then plus a squared cosine squared gamma equals c squared. Now there's one more little piece of simplifying we can do. There is a set of like terms, if you will, on the left-hand side. What do we get if we can, well, first, for what I just did, the little squiggly underline, what could you factor out? What are you left with? Which is equal to? 1, yeah. So notice that if I factor out a squared, you're left with sine squared plus cosine squared there, right? So I can write that as a squared times sine squared gamma plus cosine squared gamma plus b squared minus 2ab cosine of gamma equals c squared. And you just said a second ago, sine squared gamma plus cosine squared gamma equals 1. So we get a squared plus b squared minus 2ab cosine gamma equals c squared. And this is what's known as your law of cosines. If I cover up this part that's subtracted off, What is that? This is the Pythagorean theorem, right? If I made this go away, made this equal to 0, when is your cosine equal to 0? What do you plug in for cosine to get 0 out? 90, right? Pi over 2? Oh, if gamma is 90, what kind of a triangle do you have? A right triangle. Yeah, literally, this is just an extension of your Pythagorean theorem. It just extends the Pythagorean theorem to when you've got a non-right triangle. It changes the angle from 90 to something else. Notice, we already said that bigger angles make bigger sides, right? So if gamma gets bigger than 90 degrees, if gamma becomes obtuse, if you're bigger than 90 degrees, you're in quadrant 2. Cosine is what? Positive or negative in quadrant 2? Negative, which means it'll actually change this to plus, and it makes it bigger, right? If it's acute, it subtracts something off and makes it smaller. So it kind of makes sense, though, why that's a minus sign in there. All right, so again, we use law of cosines to help, pardon me, to help us with solving triangles when we're using side, 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 or side, angle, side, right? So notice in this first example that I have here, we have two sides and an included angle. Now notice that law of sines isn't going to help us, right? To use law of sines, I would need to know this angle or that angle to help us get that side. I don't have either of them, right? I don't have enough information. So if we do law of cosines, though, if I call this side C, then according to the law of cosines, I would do C squared equals A squared plus B squared. So we would have 29 squared plus 13 squared minus 2 times 29 times 13 times cosine of 41 degrees. Notice that the side the included angle is across from the side that's on, that looks like what you solved for, right? So I was given the included angle, I've got the C squared on this side. If I was given this side and wanted to find this angle, again, I need to make sure they're on opposite sides of the equation, is what I'm saying, okay, depending on what you're looking for. The two sides and included angle are all on the same side of the equation. The opposite side, that angle is on the other side. Is this okay? What did you get when you typed all of that mess into your calculator?
Rounded to about 21.
About 21? Was it 20 point something or 21?
It was 20.9988.
Oh, I got you. 20.9988. Okay. Is that what others got? Cool. All right. Now, unlike the law of sines, there are no ambiguous cases when using the law of cosines. Okay? So you don't ever have to worry about two triangles. You may get no triangle. The no triangle would come up if you've got two of your sides add up to longer than the third side. Okay. But there's no ambiguous case. You cannot get two triangles out of law of cosines. Okay? You can only ever get one out. All right? Because side, 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 and side, angle, side are congruence theorems. So you only get the one triangle. Okay? However, there are a couple of be careful things. Okay? And here's what I mean. Now, of course, the picture may not be drawn to scale. However, it sure as heck looks like angle A here is obtuse, doesn't it? Okay. If you try to, at this point, since I've got a third side, I can use law of sines to find an angle. Right? We've done that. Haven't we? Yeah, you've done that? Okay, I can use law of sines. However, if I try to find this angle first, remember that was our ambiguous case for the law of sines, wasn't it? One angle might be acute, one might be obtuse. So if you can, by the way, when you use law of cosines, it doesn't cause a problem. But if you want to use the law of sines at this point, you use it to find the angle across from the smaller side, not the bigger side. Okay. We were given two sides, right? If at this point you want to use the law of sines, use it to find the smaller, the angle across from the smaller side, and then you won't get screwed up. If you use the law of cosines to find your angle, doesn't matter which one you do. Okay. It's your choice of which one you want to use. But if you use law of sines at this point, go across from the smaller side. Okay. Usually students like to do law of sines to find your angle versus cosines because it's a simpler formula, isn't it? Because if I want to find the angle, I have to subtract and then divide and then do the inverse cosine. A little bit more work. All right, so if we wanted to do law of sines now to find beta, what equation would you use to find beta?
Sine of beta over 13 equals sine of 41 over 20.998.
Good. And again, to worry about rounding errors, I don't care if you write all your decimals on your paper, but make sure you keep them in the calculator. Because you'll be using a rounded number to find a new rounded number, so you can start getting some rounding errors. You should get inverse sine of 13 sine of 41 over 20.9988. What did you get for that one?
About 23.964.
And then from there, you should be able to figure out alpha from doing your 180 minus 23.964 minus the 41. And what do you get for that?
15.04.
Thank you. And notice it is obtuse, right? If you did the law of sines and didn't pay attention, you would have got the, found alpha first, you would have got the acute angle, the supplement. You would have got the, 64.96, which is not the right answer. So again, if you use law of cosines to figure out your third side, and you want to use law of sines, find the smaller angle first because it has to be acute, and then subtract to get your third angle. Okay? Like I said, there can't be an ambiguous case. There's only one triangle that works when you have side angle side. Okay? Now, vice versa, if we look at this next example, notice I'm given side, side, side. I can't use law of sines because I need an angle, right? So I'm going to have to use law of cosines. When you're using the law of cosines to find the first angle, always find the biggest angle. Okay? And then if it's obtuse, great. If it's not, then none of them are obtuse. Okay? So always find the biggest angle first. So when we do that in this case, the biggest angle will be across from alpha. Right? That's the A. We labeled our sides A, B, C, and labeled the angle gamma for law of cosines, but you can rotate the things around. So what I mean by that is your law of cosines could also be written this way. The important part, again, when you're writing your law of cosines, is the included angle is on the opposite side of the equation as the opposite side. Opposite side, opposite angle on opposite sides of the equation. Okay? Then the other two sides are just filling in the other pieces. Okay? So I want alpha, this biggest angle here, it's across from A, which is the over here. So I got it on the opposite side. Fill in the other sides accordingly. So this equation will be 14 squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times cosine of alpha. And now you can figure out what alpha is from there. Right? Now you just have numbers and want to solve for alpha. Okay. We're going to do more of these on Monday before the quiz. We'll do a quiz just over law of sines. Okay? Just over law of sines. Okay. We'll do a couple more of these before then. We'll do more as we go along for the week. But again, 2 things to remember for law of cosines. If you're given all 3 sides, find the biggest angle first. If you're given 2 sides and the included angle, find your smallest angle second after you found your side. Okay? So, biggest angle first if it's all 3 sides. Smallest angle second if you're given 2 sides and included angle. All right. If you do it that way, you won't get any issues. All right. Have a good one. Have a good weekend, everybody. We'll see you on Monday.